Yes. Today we're going to go over 3.1 and 3.2. This is kind of the intro to graphing. By the end of today, we'll know at least one graphing technique, and that'll be the brute force technique. So we'll be learning that throughout the day. In this first section, we just kind of give an overview of some of the different graph and chart types and things like that, and how to read them. One of the main things is going to be a bar graph, at least that we go over in this first section. Bar graph is a pretty decent way to show comparisons. You can see here we're comparing the different, we're comparing salaries by degree type. And so, high school graduate, some college, no degree, and it goes all the way up to doctoral or professional degree. So if we want to do a little homework assignment associated with this, suppose our homework problem asked us about some person, Keegan. We don't know if that's a boy or girl, right? Keegan plans to earn an associate's degree. They want to know what is the median income for workers with that level of education. Well, if we want to know information about something here on the bottom, we just follow its graph up to its peak, and so I go associate's degrees all the way to the peak, and then I follow that over to my other axis. So I say, yeah, that's about $800 weekly. Sometimes we're asked to do this the other way. So we've got somebody named Isabella who wants to make at least $1,000 per week. In that case, we go first to the vertical axis, and we say, well, here's $1,000. Now let's see what kind of education we need to get that. And so that's at least a bachelor's degree. So that's it for bar graphs. Those aren't going to be a main focus of this chapter. This stuff will be a little bit more of a focus, though, these kind of continuous graphs. So for this particular graph, this is a graph that tells a person's heart rate after months of successive exercise. And so the months of successive exercise are on the bottom here, and the heart rate, the resting heart rate, is over here on the side, on the vertical axis. The first part of this question says, how many months of regular exercise are required to lower the resting pulse rate as much as possible? Okay, so this line represents the resting pulse rate, and so they want to know, when is this line the lowest? It looks like 6 right here. Let's zoom in. Yeah, it looks like on the 6th month, we're just a little bit lower than the rest. Not by much, but it is lower. So that's where the graph is at its lowest point. So we're going to say part A, how many months of regular exercise? So we're going to say 6 months. Part B says, how many months of regular exercise are needed to achieve a resting pulse rate of 65 beats per minute? Okay, this is kind of like on the last equation where we looked up the vertical axis first. All right, so 65, right in between 60 and 70. Let's follow that over to the graph. That looks like about 3 months. Okay, so we would say B, 3 months. Whoops. Which is good for me, because that means I'm only 3 months away from a 65 beat resting heart rate. Get it? Because I don't exercise. Never mind. Okay. All right. So the next thing we're going to do is talk about graphing on the plane. So far, we've graphed on a number line. That's kind of a one-dimensional graph where we just say, well, where's x? X is right here if x equals 3, and boom, we're done. Right? In this chapter, we're going to actually use 2 number lines lined up perpendicularly. And we call that a plane, right? And so this is a 2-dimensional plane.
Are you going to be putting screenshots in there again?
Oh, sorry.
It's like flying.
Sorry.
Try to make notes and listen at the same time.
My apologies. Am I going to what?
Are you going to put more like screenshots in there?
Screenshots?
Yeah, like graphs.
Oh, not a whole lot more. No. Oh, I should have given you guys time to draw that stuff out, huh? Sorry about that.
Well, I was going to turn off the light so I could see it.
Okay, those are, so at least the screenshotted graphs. Do you want me to turn off the lights? We can. Yeah?
Do it.
Yeah? Okay.
And I'm blind already. Yeah, I don't know where my glasses are.
Okay. Let me know if you want me to change that though, okay? Okay. Hey, we need like a reading lamp in the corner or something, right?
Okay, so
We want it rendezvous for like $1.
we're
Yeah?
graphing this and we're figuring out x equals 3, right? And so we're just
Yeah, so what we did up here, I'm just saying, like, this is what we've been doing so far, right? And what we're going to do now is we're going to take two different number lines and locate sort of the intersection of 2 points. So when we get there, this is how we set this up, right? And so we just have two number lines. One is vertical, one is horizontal. We always call, unless otherwise instructed, we always call the horizontal one the x-axis. And unless somebody tells us otherwise, we always call the vertical one the y-axis. It's important to sort of work those out in your head so you're used to thinking of horizontal as x, because soon we're just going to start throwing stuff up on there.
Or you could just keep looking at the graph you wrote on your notes.
You could do that. You could do that. That's always an option. Okay, so, instead of like on the number line just plotting one point, to plot a point on the plane, first, we plot x, or we find where x is, right, on the axis. And I'll show you how this works in just a second. Then we find where y is on the y-axis, right? And then finally, we draw lines perpendicular from each of those points, and where the lines intersect, that's where the point is. That's a complicated way of saying what I'm about to show you. Okay? So, and here, let me just give you an example. Suppose I want to plot the point. Whoops, I almost wrote x there. I don't want that. Suppose I want to plot the point 3, negative 1. Well, these are all in the form x, y. This is a good thing to get used to, is thinking about x, y as the standard form here. So first, we find our x value on the x-axis, right? So I go over to 3 on the x-axis. That's right about here.
wait, I'm sorry, I gotta ask a question.
Yeah, please do.
Why are we going with x, y and not y, x?
Oh, so the standard is that the variables will go in alphabetical order,
No matter what.
unless otherwise stated. Yeah, and so if there's no instruction and you have A, B, C, or sorry, A, B would be more appropriate, A comes first. Unless they tell you B comes first, which they don't do very often. So, yeah, good. That's an excellent question. Yeah, so X is always going to come first unless for some reason we define it otherwise, which we won't in this class.
So we're gonna plot 3 first.
Yeah, so you locate 3 on the x-axis. That's like right here. Then you locate negative 1 on the y-axis. That's down here. Now, you take these, right, and you trace out a little line. I'm just going to dot here. I'll zoom in. So you trace out a little dotted line from each of these. Sorry, that's not a very straight line. And where they intersect is the actual point. Okay?
This is way different than how I had to do it before.
That's okay. Right? This is the point 3, negative 1. Notice what we did here. 3 came straight off of the x-axis. Negative 1 came straight off of the y-axis. Right? Any questions? Not too bad? Okay. Right? Here, let's try one more before we move on. So suppose I wanted to plot the point. I'll draw it down here. Suppose I wanted, let's see, negative 2, negative 2. Well, I'll use my little green highlighter for this. So for this, I go to negative 2 on the x-axis, which is right here. Right? I go to negative 2 on the y-axis, which is down here. And then I'll just keep using the highlighter for this step. And then I trace them over and trace them down. Right? Whichever direction the other point is in, that's where I trace them. Where they intersect is where the actual point is. Okay? So,
I kind of zoned out in that graph. It's real weird.
Well, you missed it forever. Let's just go home. Just kidding.
Looks like Shrek.
Yeah.
Like, it's like a little dog.
We're going to, and I'm maybe jumping ahead in questions, but one of the other math class I took has graphing.
We're not even close to there yet.
Okay, cool.
That comes later. Yeah. Yeah, this is a single point. When we graph lines, that's graphing like an infinite number of points.
Okay,
Yeah.
We're gonna do it.
Yes. Oh, don't
Like,
worry.
When I look in the answers in the back of the book, I just see like pages and pages of graphs.
Yeah. Yeah. It might help you guys to go grab some graph paper from the student center before you go home tonight, just so that you don't have to draw out these graphs like where I work.
Elaine knows where they
Yeah.
You all can work on it.
Yeah. Okay, so definitions related to graphing. When we ask you to plot a point, that's exactly what we're asking you to do, is locate that little cross section. The number lines that we used are called the axes, right? So we have the x and the y axis. That's the singular term, is axis. The point where they cross, that's known as the origin. Now let's try and graph another one of these. So, I'm asked to graph the pair -1, 5 here. And I'll give you guys a second. That takes a while to write down those definitions, doesn't it?
Wait, the axis is the 4 lines, not the little ticks.
Yeah, the axes are the actual like number lines. Yeah. And each number line is an axis. Which is weird. Which is strange. That makes me think of that historical term, the axis of evil.
Yep.
And it's like, wait a minute, there were multiple members. Shouldn't those have been the axes of evil?
Somebody messed up in there.
When you're that evil, it doesn't matter. You're just like, whatever, we'll take the singular.
5-0, like Dave.
Okay, so here we go. Consider the pair -1, 5. I'll use my green highlighter again. So first, I plot the point -1. That's on the x-axis because it comes first. Now, the point y equals 5. Okay, that's way up here. Now, I extend these out to find their intersection. So I'll start with -1, and I know that 5 is above, so I'm just going to go that direction. Right? And when you're plotting these, you don't have to show the line that I'm drawing in right now. I'm drawing this in just for the demonstration. When you plot these, it's totally fine just to plot them directly. If you draw in the lines, that's fine too. So, this point exists where these two lines cross, which is about there. And now I want to label that. That's what I really should do on all my homework problems, is label every, if they're asking me to plot a point, I want to label it when I'm done.
Yeah, when you do the homework.
Yeah. This is what I do every time I do the homework. All right. Any questions? Not too bad. Okay.
That was perfect.
Yeah. All right. So suppose we're asked to identify the coordinates of each of these points. Okay. So point A. I'll just write out a little A over here. A equals the point. The x value of A, I'll just trace it down. The x value of A is 4. So I plug that in there. The y value of A is +3. So I plug that in there. And I've found the point A. Now I start over, find point B. Okay, B is up here. I trace this down to the x-axis, directly down, and I find -3. Then I go over, and I find +5. There we go. There's my B coordinate. my C coordinate. C equals, you can see that C is where x equals -4 and y equals -3. So, -4, -3. And we're just going to keep going on these. What do you guys think? Let's see now. Oh, okay. Should I slow down?
I'm just flying.
Should I chill?
You should hand us out these screenshots.
These are in your book. This one specifically is in your book.
Okay, well, I'm drawing out my book on my graph paper.
Gotcha. I'll give it a second
I'm
then.
going to depreciate value now. I think where my
So
But I'm grasping the concept.
So don't yell it out yet, but think to yourself and maybe even write it down on your page. If we were to label this point D, what would we label it as? Think about it. Right? Okay. Hopefully you guys got 2 for the x value and -4 for the y value. And just so you know, like a question on your next exam will be this, except for in reverse. I'll give you a list of points and I'll say plot these and label them, and there you go. And so just by learning how to plot and label points, you're going to get the first question correct on the next exam. Yay. Okay, so now let's go ahead and find E. For E, what's the coordinates of E?
You want us to say it?
Yes.
Oh, 1, 5.
Okay, good. Sorry, I should have been more specific. I did tell you guys to be quiet on the last one, huh? Yeah. This is like a game of Simon Says here. 1, what? Oh. Holy cow. Don't know what I was thinking there. That's okay. They figured it out by now. It's fine. All right, so D, E, F. We need F here. How many points are they going to put on this thing? Okay. F. Oh, this is actually a really good one. I'm glad they put this one on there. So this one, the point is actually on the axis, right? Yeah, so this is weird. So basically we say, well, this is x equals -2. That's pretty clear.
Right, that's 0.
Yeah, and then 0 is the other one, right? If it's on the axis, then it's on the 0 line.
One of the things that always confused me the last class I took was whether it was 0 first or after.
Oh, it depends on which axis it lies on. Yeah, and so if it lies on the horizontal axis, then y is equal to 0. But if it lies on the vertical axis, then x is equal to 0, as we'll see on this next example. So the next point is going to be G up here. I'll write that out right here. G equals. And so for G, we notice that one's on the y-axis, right? And so y is equal to 3, but x is equal to 0. Okay. Oh, how about this? If I put a point right here, what would it be? Oh, good, 0, 0. The origin. Yeah. Okay. Any questions about those guys? I'll give you a couple more seconds here. Yeah, so plotting points is pretty straightforward. The mistake where we mess up the x and y axis happens on this next exam far more often than anybody ever would think that it did, so just be careful. Make sure that you remember the y is the vertical and what order they come in. Okay, so the next little thing we're going to go over is quadrants. This is also something that we're not going to be tested on. It's nice to know, though. If you go to trigonometry, this is super important. But the quadrants are just so that we can locate what part in the plane each point is in, right? And so, what's that?
It goes backwards.
It kind of does, right? Yeah, it's going counterclockwise. That's weird. Mathematicians are weird, though, right? So just so we know, if I have a point in this quadrant 1, let's say my point is somewhere up here, and let's say the point is just equal to x1, y1. Are these two numbers positive or negative? Yeah, they're both positive, right? That's the nature of every point in quadrant 1. Both of those numbers will be positive. Okay? Now, if I took just a random point over here in quadrant 2, let's say it's this one, and we'll call this x2, y2. Which one's negative and which one's positive? Right? Because on the upper half of the plane, y is all still positive, right? And this is on the upper half of the plane, so this is positive. But the x, yeah, the x value will be negative over here. Okay?
Why is there a 1 under it?
Under what? The x?
Well, and now we're on 2.
Oh yeah, I'm just showing like these are not the same variables, right? That's something that you can do when you want to use x's on a lot of different things. Like suppose I had 3 different variables, but I really liked x for some reason, which they do this in statistics. You could call them x1, x2, and x3. And you could say those are 3 different variables. Not very often. There are a little bit of these, though. Yeah, with some of the graphing formulas, they have they call them subscripts. And when you talk about these, you can call this x sub 1, x sub 2, and x sub 3. Okay, so now for a point over in the third quadrant, right, we can call this x sub 3, y sub 3. Are these going to be positive, negative? What do you guys think? Yeah, both of these will be negative. And then finally, our last option, x4, y4. What do you think? Will x be positive or negative? Positive. What about y? Good. Good. There we go. So yeah, that's kind of like how the quadrants work. They can be pretty handy later on. In this class, we won't focus in on them too much, but just know that they kind of like, the signs change as you shift from one quadrant to the next. All right. Let me see. That's it for that page. So obviously, as I say here, you guys have seen graphs with different scales on them, right? Like we were looking at one earlier with thousands of dollars on the side. Whereas when we create them in class, we like to use just the integers 1 through 5. The difference in this is called a difference in scale. So these two graphs are examples here of graphs with different scales. The graph on the left, you can see that each tick mark differs by 1. So this graph has a scale of 1. This other graph, though, each tick mark has a value of 10. So this one has a scale of 10. Different axes can have different scales if you want them to. Right? And that's a perfect example is those ones that are like, how much money do you make per year, right? You're counting off 1 year, 2 year, 3 year, but the money is going up by thousands. And so they don't have to be the same scale. That's it for that page. Aha, the example. So here is it's a kind of a tedious example, and just know that it sort of makes sense. It's just tedious. Just know that this won't be on the exam. This is good to know and sort of like recognize why we're doing this, but I'm not going to ask you to squeeze a certain amount of information into exactly 10 blocks on the exam. But they might ask you to do it in your homework, so it's good to pay attention. So right here they've said, use a grid of 10 squares wide and 10 squares high to plot these 3 numbers.
So we're making a graph.
We're making a graph, yeah. But first, before we make that graph, we're going to consider the x-axis and the y-axis separately, and then we're going to put them together in the end, okay? So first, I'm going to list all my x values. I have negative 34, 48
Scribble.
and 10. It's, I don't know, it's something I write besides an equals sign. I guess I should just say equals though.
Well, I thought
Doesn't
you were
matter.
gonna do the like,
Oh, like this thing?
yeah.
No, I usually, I draw that stupid little curved line just when I don't want to draw an equals sign, because it's inappropriate to put an equals sign where it's not equals. It's my own weird hang up. Like you guys would never notice if I just threw equal signs in somewhere, but it would bother me constantly up here, so I do it for my own sanity. All right, so I list all my x values, right? And then I find the total range of x values. Okay, so I find my highest x value, 48, and I find the difference between my lowest x value, which is negative 34. So 48 minus a negative 34, that is equal to something.
This is not going to be on the exam,
Nope.
but it's going to be in the homework. Right?
Yes. Yeah, it'll be in the homework. And so, like, you know, if you're struggling with this on the homework, which you probably, you might, I mean, I have to review this every time before I do this particular exercise. You know, if you're struggling with this on the homework, don't freak out about it. It's normal. This is really weird stuff that we're kind
Well,
of...
I'm freaking out because I don't know what you just did there.
So what I did was I found the difference between the highest number and the lowest number, right? And so I found basically the spread of the points.
Why?
I'll show you in just one moment.
Okay.
So this is kind of the part where you get to sort of figure out what you want to do. So I say I have an 82 point spread, right? This information spreads 82 full points. So I want to split that up into 10 different sections. So I have 82 divided by 10. That gives me 8.2. Right?
Okay, wait,
But-
wait. What did you say that you said, because I want to write it down.
Oh, okay.
What did you say you were doing with the 48?
So with this stuff up here, this 48, this is the highest x value. This 34, this is the lowest x value. And so I wanted to find the distance in between those so I could split that distance up into 10 equal parts. They're not going to be exactly equal though, because 8.2 is not, nobody's going to do an 8.2 scale. That's too weird, right? So when you're doing this, it's totally appropriate to round up, especially in this class where, you know, I'm not gonna be a stickler about these. So I say, okay, 8.2, that's pretty close to 10. There. Okay, so I need a scale of 10 on my x-axis. So I start at 0, and then I need to make my tick marks out until I get to my lowest value. So negative 10, negative 20, negative 30, negative 40. Right, my lowest value is somewhere right in here. You don't necessarily need to plot that point, but I like to do it just so I can see what I'm doing. Now we want to go in the other direction. My highest value is 48. So I have 10, 20, 30, 40, and 50. So there we go. So now this is basically what my x-axis is going to look like, right? Except for without those red dots on it. That's going to be my scale for the x-axis. Now for the y-axis, we do the same thing but with those numbers, right? The y values are these ones here, 450, 95, and negative 200. So I have my, whoops, that's an x, not a y. I have my y values, here's my little curvy line again, are 450, 95, and negative 200. Okay, so the lowest number is definitely negative 200, the highest is definitely 450. I need to find the difference in between those two, right? I need to find the distance in between those 2 points so I can split it up into 10 spaces. So I have 450 minus a negative 200. Right? The reason for this double negative is because difference means subtraction, right? And so I'm subtracting the lowest number. So this is equal to 650. Now, remember we wanted to split this into 10 sections, so we're going to divide 650 by 10. Boom, 10. This gives us 65. So in a perfect world, our tick marks would be separated by exactly 65. I'm going to round it up to 70 because, why count all those fives like that? It's totally appropriate to do this in this class. Maybe very high-level classes, you'd want to be very exact, but to round up is just fine here. So I'm going to say 65, that's roughly equal to 70. So I'm going to go 70 per tick mark. If you want to do exactly 65, that's okay too. Okay, so now that I know that each tick mark needs to be worth 70, I go back to my little y-axis. I mark out 0, and then I'll just find my lowest number first, right? Negative 200. So I need to remember that each of these is worth 70. Negative 70, negative 140, negative 210. So the negative 200 fits in here. Now I count out the other direction. This time I'm going all the way to 450. So I have 70, 140, 210, 280. I should just zoom in for this really. Let's see now. 350, yeah. 420. Wait. Did I do that wrong?
I'm still on x-axis.
49, yeah, 490, you're right. Okay, thank you. Thank you for getting me through that crisis of confidence there. All right, so there we go. So I went all the way up to 490, right? The point that I needed to fit in there was only 450, so that fits in. Now I take both of these scales that I've figured out separately and I put them all into one axis. Okay, so I'm just going to zoom out a little bit to do this so I can see my tick marks. Okay, so on my x-axis, I have marks of 10 each. So I have negative 1, negative 10, 20, 30, 40.
So what if you still don't know what's going on?
That's okay. This is a weird example and it's really tedious. And honestly, it's not very often that people pick it up right away. This homework assignment is a little bit, it can be a little tedious when you get to this problem specifically. So give yourself a little extra time.
So I should do my homework in the student center.
Yes, that'd be a good idea. Yeah. And I mean, if you run into problems on this and you're starting to get frustrated, it's totally okay to just put it down. Come see me about it before class on Tuesday, like with all the other stuff done, of course, and then we can work this out. Okay, so that's my x-axis. Now I need to count up in the positive direction, 10, 20, 30, 40, 50. Okay, now on the y-axis, I need to copy this, except for on the vertical. It's kind of a pain. Okay, so let's see now. So I'm counting down with ticks of 70. So that's negative 70 there, negative 140 there, negative 210 here. Now I go up. 70, 140, 210, 280, 350, 420, and 490. Finally. You can see it's not very pretty, but it is correct. So now, I think they've asked us to plot the points. Let's make sure that's in the instructions. If it's not, then we're done. Use a grid, 10 squares y. Yeah, they say they want you to plot these points. Okay, fine. Right, what is their problem? Can't they just give us nicer points? Okay, so I'm just going to write these on the side here. 10 and negative 200. Okay. Now I just need to locate these 3 points in the plane that I've just drawn up. Okay, I'm just going to label my axes real quick. You don't really have to do this, but labeling your axes is nice to get, just to get it into a habit. So the first point, negative 34 and 450. All right, so we'll go over to roughly negative 34 over here on the x-axis. That's like right about here. And then we find 450, maybe right about there on the y-axis. And these points intersect, whoops, it looks like right about there. Okay, now I label this.
No, not shrink it.
Oh, okay, sorry, blow it up, I thought you said pull it up. I was like, okay. Is that a little bit better? Probably doesn't help that you couldn't read my handwriting if you were right up next to it. So now I label this point. And notice, on this one, I didn't draw the lines to the point. That's something that you'll wanna get used to not doing after a while. After a while, you won't even want to make these ticks on the axes because that can confuse things when you're graphing a bunch of stuff. All right, the next point, the point 48 and 95. We go to roughly 48 on the x-axis and roughly 95 on the y-axis. I don't know, somewhere in here. Maybe right there. So as you guys are doing this, just remember that I don't expect you to complete your graphs any more perfectly than I do, which means that if you're way off, that's okay as long as I can tell you graphed it correctly. Right? Like if your point is maybe, I don't know, suppose you made your point over here and it wasn't exactly in line with where they were on the x-axis, that would be okay. Right? But if you made your point in a different quadrant, then we'd have a problem. Yeah, so I recognize that these graphs are not super accurate. So if you're not exactly where the point is, it's okay. All right, last point. 10.
Giving up here.
Okay. 10 and negative 200. Okay. And like I said, I know this is a tough part of the lecture, but don't let this bog you down because this isn't going to be on the exam. You're just going to have to deal with it on the homework. The next stuff is more important. All right, 10, negative 200. So I have 10 on the x-axis, negative 200 on the y. That point is somewhere right about there. So there we go. And if you just estimated on your homework and you didn't go through all those steps, it would be okay. I'm not looking for all those steps on this problem. I do all those steps because that's the way they show it in the book, and I don't know, I feel like I have a duty to do that, at least with this one.
If you didn't do all those steps, you'd be like, I don't even know what's going on. Which I have done, but I think I get it now.
I missed the 95. I'm like, where the fork? It's the 95.
The 95? Oh, that's right here.
Where is it on the?
Oh, it's right here too. There you go.
But not on the graph.
Oh, okay.
Chart.
You mean the specific tick point of 95?
Yes.
It's not on there. So that's actually a great observation, right? Notice that a lot of these were not exactly where the tick point lied. So this one, I just thought, well, 95 looks like it's right about here on the y-axis.
And that's where I'm
Yeah. So estimation is fine if you come up in between the tick points. That's totally fine.
I had it for everybody else. I legit had it for everybody else, but I missed it for that one. I had so many other. Oh, my sweet cheese and rice. That
Sweet cheese and rice. All right. So that was the intro section on graphing. I hate doing that last example, but it had to be done.
Yeah, and we're only halfway done.
Yeah. No, the rest of this stuff is far. It's just.
your brain on graphic.
This next stuff is not nearly as bad. Okay, so okay. So let's notice real quick. Notice that we introduced a new axis. We started working with two different variables, right? And so before we were just graphing x on a number line. Now we're graphing x, y in a plane. When an equation contains two variables, the solutions always come in ordered pairs, right? Those ordered pairs that we were just talking about, x comma y. Okay, each number in the pair replaces a variable in the equation, right? And so for this equation, 2x plus 1 equals 3y, the solution set it's going to look like this, right? Except for you're going to replace those with specific numbers.
Seriously, who's copying right now? You're in class.
I don't, oh yeah, I can.
That was horrible.
Right? Like, do we not have a can of WD-40 somewhere? What's the deal?
I think maybe I had death in my left ear, that heavy metal, but my right one's like.
Okay.
Wait, so you're going to have 2x plus 1 equals 3y, which is the solution set in the form of x comma y. So somewhere with x and y, that's going to be, okay.
Yeah.
Okay. I had to make sure I had it.
And I think we mentioned this earlier. We did. But the order of the variables in the pair is alphabetical.
Right.
Unless otherwise stated.
Got it.
Might even stated otherwise. So
That's cool.
it looks a little weird.
Unless stated otherwise. I think they're the same.
Okay.
Okay.
Probably.
So for this particular equation, 4b minus 3a equals 22, I'm asked to determine whether this is a solution set for this equation. So remember, to figure out if something is a solution to an equation, we draw out our little table and we put our equation on top. So I have 4b minus 3a equals 22, and our table gets drawn out like this. Horizontal line under the equation, vertical line under the equals sign. And then on the first line, we start plugging things in and we see if it leads to a true statement. So which one of these, I have 2 and 7 here, which one of these should I plug in for A and which should I plug in for B?
Oh, we're doing the tree again.
Yes, A equals 2, B equals 7. Right? We know that because they have to be in alphabetical order. Right? It's not stated otherwise, so 2 must be A, 7 must be B. So now I'm going to go ahead and plug these in. Right? I have 4 times B, that changes into 4 times 7. Then I have negative 3A, that changes into negative 3 times 2. And I have to make sure that this does equal 22. Let's see if it does. 4 times 7 is 28, I think. Yeah, 28 minus 3 times 2, which is 6. Aha. And what we find here is that this leads to a true statement. So yeah, these are solutions. Yes.
Why are we doing this on this and not graphic? So it's just another section?
So this is going to tie in the relationship between solutions to an equation and the graph of an equation. They're pretty much equivalent. And we're also this is also I try and me and the book, we try and give you guys ways to check your work. And so previously we've seen how to check a single variable equation. This is how to check a 2 variable equation. Okay, now let's check this next pair. Okay, I do the same thing. Create my little table here with my extremely straight line. And then I write out my equation, 4b minus 3a equals 22. Draw my vertical line here. And so now I have a equals 1 and b equals 6. So now 4b becomes 4 times 6. Negative 3a that becomes negative 3 times 1. 4 times 6, that gives me 24. 3 times 1, that's just 3, so 24 minus 3. 24 minus 3 is 21. It was supposed to be equal to 22, though. That's a false statement. So, no, that is not a solution. Right? If you reach the bottom of this and you have a false statement, this is obviously false, then the numbers you plugged in were not correct. Okay?
Is that backwards or am I,
Is what backwards?
shouldn't it be 4 times 1 and then 3 times 6?
Oh, hey, no. I got it right. Yeah, because b was equal to 6, right? We have b equal to
Right,
6 here,
Then you put,
and I have b here.
then you go down, and I thought it was 4 times,
Since the equation was 4 times b, then it's 4 times b down here as well. Right? And so see how I replaced these two blue things.
yeah,
I just
ignore me, I had it backwards.
got it. Okay. Yeah, and I mess that up sometimes too, especially when they use something other than x and y. That can be a kryptonite for me.
How dare they?
Right? Leave it in x, y. Okay.
No, I just had it the A and B flip spots.
Okay, so now this is where this stuff kind of ties in a little bit more with our graphing. So we're asked here, I'm just going to erase this stuff. We're asked here to show that these three pairs are solutions to this equation. Oops. I keep getting the erase button. To this equation. And then we're asked to graph those 3 points and draw a line. Okay, so first things first, we're going to use the point 3, 7. Oops, that's not the equation. So my equation, I write it on top of my table, is just y equals 2x plus 1. Okay, and remember I have x and y here. So if y is equal to 7, I just plug that in on my left side. If x is equal to 3, I plug that in as well. So 2x becomes 2 times 3. And we end up with 7 on both sides. So yeah, this one's good. Let's keep going. So the point 0, 1, let's try that out. Make a new table here. 0, 1. Okay. So y is equal to 2x plus 1. And now I plug in 1 for y, and then I plug in 0 for x. 2x becomes 2 times 0. Two times 0 is just 0, and I end up with 1 equals 1 at the end of this table. So yep, this one is also a solution. Finally, we're going to check the third point. I'm just going to scroll down a little bit and do it below. Okay, so the point -3, -5. Y equals 2x plus 1. I draw my vertical line where the equals sign is. Y is -5. And 2x becomes 2 times -3. I have -5 on this side and -6 plus 1 on this side, which gives us -5 equals -5. So yep, all three of these points are solutions to this equation. Oops, -5. Uh-oh, problems. How do I get rid of this thing? No, leave me alone. There we go. -5. Okay, so I know all those are solutions.
Wait, go back over.
Oops, sorry.
Yeah, me are behind.
They're all solutions.
Yes, all solutions.
Everybody is a winner. Okay.
Winner, winner, winner.
Wait, I'm not ready.
Not ready?
Sorry.
It's no problem at all.
Better not be, because I hate being hurt.
It's all good. You're not a burden. This is algebra. We're just chilling. Okay. I think ready now?
Yeah,
Okay.
thank you.
All right. Now we're going to plot all these 3 points. Should I give you a minute to set up an axis? Yeah? Go ahead. Set up your graph so you can do this next part.
Do we have all the way to 7?
Yes. And that's a good point. My graph does not go to 7, so I'm just gonna extend it up here until it reaches there.
Yeah, just say how far.
Okay, so the first of these points, so these first of these points is the point 3, 7. I go 3 on the x-axis, and then all the way up to 7 on the y-axis. That is, right about there maybe. 3, 7. The next point would be 0, 1. So that point, we don't go anywhere on the x-axis, but we just go up to 1 on the y-axis. So it's right there. Finally, we have this double negative point back here, -3, -5. Right? We know where that's going to be. It's going to be down in quadrant 3. So we go -3 on the x-axis, -5 on the y-axis. That is right about there. Now comes the final part of this. So they wanted to graph, So they wanted to graph all these 3 points and connect a line. So I'm going to draw a straight line which never hits all my points because my graphs are so sloppy. Oh, actually that didn't do too bad. Okay, so all 3 of those points lie on this line. That line is the representation of this equation. And so any point that you choose on this line will be a solution to that equation. Okay, no matter what point you choose, it's gonna be a solution, right? Want a solution? There's one here, there's one over here, there's one way down here, right? That whole line, that's a graphical representation of all the solutions of this equation. Okay, so the problem says graph 3 points to find one more. Okay, so we have to try and find a point that's on this line.
3, 2.
You think 3, 2? Wait, what? No, 3, 2 is like right here, right? You're thinking 2, 3. Haha. 2, 3? I don't.
I said 3 and 2. I did say comma.
That's true. That's true. So I'm thinking, I'm kind of leaning towards this one down here, and the reason is because it looks like it lands on -1, -1. But I'm going to try that point.
My line looks like this, so you can't really
and that's okay. That's okay. So I think another point on this line is -1, -1. So I'm just going to check to make sure that's actually a solution here. So -1, -1, question mark. I draw out my original equation, y equals 2x plus 1. Draw my vertical line in. And then I say, okay, y is equal to -1. If x is equal to -1, then I have 2 times -1 plus 1. And here we can see that we have -1 over here, -2 here, plus 1. So yeah, this comes up with a true statement at the end.
The answer.
Well, I did. I didn't want to pick one that didn't work because we have like 25 minutes left, and so like yeah, I didn't want to. You're right. Gee, -1 looks pretty nice. Okay, so let's see now. Oh, for a summary of important facts, there's a little table on page, or a little informational box on page 164 with a lot of this stuff in it. What's that? So let's see now. This specifically won't be on the exam, but a lot of stuff related to this will be on the exam. And the conceptual stuff behind it is very important. It's really important that you realize that this straight line that we just drew is a graphical representation of every single solution of this problem. And what we're going to learn next will help you out on exams. Well, this stuff will too, but it's not directly applicable. Okay. Everybody good with that page? Yep. There's a lot of stuff going on there. Okay. Okay, so let's talk about graphing linear equations now. The equations that we've dealt with so far in this class are mostly linear. What I mean by a linear equation is a straight line, right? And so, if this were my little x-axis, this is not a linear equation. That's a curve, right? A linear equation is only a straight line. So what we're about to learn is what I consider the brute force method for graphing. It's a little bit tedious to carry out the brute force method, but something that you should always remember, and I won't fault you for this unless I specifically tell you to use a certain method, you can always fall back on this. Okay, so if you don't remember the little tricky methods I'm going to teach you soon, you can fall back on this every single time. You can fall back on this with far more complicated problems too. It doesn't have to be a straight line for this to work. If you test enough points with the brute force method, you can graph all sorts of weird, crazy stuff. I'm not going to make you graph all sorts of weird, crazy stuff with it, but it's good to know it.
Just going to come back as like a mad scientist if you make us do all this.
That's okay. I'd call that a win. Well, depending on what kind of mad, if you guys were evil, I'd be a little disappointed in you.
I'd make you
unless your math was
with
solid,
math.
then it'd be okay.
Yeah.
Okay, so here are some, and so even though the brute force method will always work in almost every situation, especially that you're going to run into here, just remember that this is not the most efficient method. Okay, so if you want efficiency, the other methods will be good. And you're going to want to learn them all. But this one you can always fall back on. So here are some examples of linear equations. Right? Y equals 3x minus 1. You don't need to write these down or anything. These are just examples. This one right here, y equals x. That's an example of a linear equation. The thing that makes them linear is that there are no square terms. Right? When you have equations that have an x squared in it, that's a key indicator that it's some sort of curve somewhere, or a y squared or something like that. When it's just plain x's and y's and we're just messing with numbers in those and not squaring them, it's pretty much always linear. And so just like I said previously, a graph of an equation is a visual representation of all of its solutions.
As long as you don't make us do 93 in chapter 4.3.
All right, well, now that you said that, I'm going to have to assign it. Because
You already hand out.
I know, it is too late, huh? It was, yeah. Tyler, you said on your exam that you refused to do questions with pi. And I was like, well then, I'm going to put pi in every problem on the next exam.
I mean, I also knew that I knew how to do it and I kind of forgot got, and I was like, if I do this wrong and do this, it's worse than just like.
Only one person attempted the extra credit, and only one person got it absolutely correct.
Okay, well,
Good job.
No, I'll show you guys how it went later on, and really like the key to that extra credit was just ignoring that there's weird variables in there. Like there's like that backwards y that they call mu that I put in there, and I just put that in there purely to mess with you, including the smiley face.
Yeah, I was more mad about wait, was the smiley face supposed to be a variable?
Yeah. Yeah.
I thought you were just like making that appear.
Yeah, instead of like pi x, it was pi smiley.
I thought that was your period.
No, because in the description I said,
gotten it very wrong anyway.
probably. In the description I said, like, let mu, a, and b, and smiley represent real numbers. And so...
Yeah, I thought you just kept using that as a period. I was like, that's fun.
That's fun.
Happy for him.
No, it's part of the equation. All right. On page 165, here again are going to be some sort of algorithmic instructions on how to graph these linear equations. And so this is sort of the step-by-step instructions on how to do a brute force. And so let's go over these real quick. So to do a brute force graph, all you do, right, is you want to solve for one of these variables, right? Right here we've solved for y already. So I'm just going to...
When?
It's already there, right? We have y equals some stuff, so y has already been solved for, right?
Like a variable, y equals. Like, I can see that.
So with this one, we want to just set up a table. I know how much you guys love tables. X coming first, y coming second. Now, in these tables, all we do is we plug in values for x, and then we calculate what y must be according to that value. So first thing, I'm going to choose x equals -2. And I'll tell you why I'm choosing these values in just a second.
Because you already know them and we're running out of time.
No, this one's very much for convenience sake. I would recommend you take my strategy when you're choosing stuff. So I say, okay, x equals -2, and then I do some scratch work over here, and I say if x is equal to -2, then y being equal to -3x plus 1 is equal to -3x, -3 times -2 now, plus 1. So basically, I choose a value for x, and then I plug it back into the equation to find what y must equal, okay? And so on this next step, I do the math. -3 times -2, that's a +6. So y equals 7. Plug it in. Now I've just found the first point of my graph.
So how do we figure out where the -2 was again?
Oh, you mean like how did I know to plug that in?
Yeah.
I'll go over that in just a second.
Okay.
In the end,
I'm trying to do the thing over here, and
yeah, don't worry about it. I'll show you guys why I'm plugging those in as I am in just a second. And in the end, you're the one who gets to choose what values for x you plug in. I plug in a specific set of values because they're more convenient. Other people, maybe they go after the weird values.
6?
No. In other problems we could. Not in this one, though. Not in this one. That's a good question. So one that you always want to do is 0. Okay, because that's easy. Let me show you why. I go over here to my scratch paper side, and I say now if I replace x with 0, I have y equals -3 times 0 plus 1. Right? -3 times 0, that's equal to 0. So y is equal to just plus 1. I fill that in my table. Finally, I want to choose one more point, right? You only need 2 points to make a line, but you want to do 3 just in case. It's kind of like a nice little check. So the last point I'm going to choose is +2. Ooh. You see a pattern here? All right, I go over to my scratch work over here on the side, and I plug in +2 for x. So I have -3 times +2 plus 1. That gives me -6 plus 1, which is equal to -5. There we go.
Wait, 5. What did you do?
So I plugged in 2 for the
Oh,
for
yeah,
X right
I
here.
put a negative in front of my 3.
Yeah. Okay. Now that I've plugged in all 3 of those values, I plot the points. So I have the first point being negative 2, 7. So let's see now. Negative 2 on the x-axis. Oh, I had to extend my y-axis a little more again. I always have to do this. 6, 7. Okay, so negative 2, 7. I'm going to make that point. Let's see now. Negative 2 on the x-axis. Trace that up to 7 on the y-axis. That's right about there. Now I'm going to plot my next point. 0, 1. 0 on the x-axis, up 1 on the y-axis. That's right here. Now the last point. 2, negative 5. Positive 2 on the x-axis, and then I have to go down to negative 5 on the y-axis. Right about there. Now I'm going to connect the line. And that's pretty ugly. You can see what happens when you make sloppy graphs like I do, but it's okay. Okay. So now we've graphed this line by basically just introducing points of x and solving for y. You can choose any points for this column that you want. The reason why I choose negative 2, 0, and 2 is because all those are just symmetric right about the axis, and I like symmetry. And it just, I don't know, 0 is very easy every time, right? Why not choose one before 0 and after 0? To me, that makes sense. Depending on the different equations that you come up with, these points might be more convenient to be different specific numbers, but just in general, you want to pick something in the negative, pick 0, and then pick something in the positive.
Yeah, Miss Kaiser in Revilla that is now retired talked that.
Nice. Good. Good for Miss Kaiser.
Yeah, she's great.
Yeah.
She
And
hated me though.
I'm sure it was undeserved.
Well, she had a love hate.
Oh, okay.
She still showed up for just my graduation, even though she was retired, just for me.
That's awesome.
Yeah.
That means she did like you, okay? Yeah. You don't go to the graduation.
She got really mad at me though at the end of the day. You know, just get her out of my face.
So, you might be tempted to choose negative 1 and 1 right here, and that's okay, but your spread gets really tight when you choose that, and the closer those 3 points are, the less accurate your graph is going to be. So I like to choose a little bit more of a spread, but like I said, these points, these really are up to you.
Just so like when we're
Negative
correcting
6.
something ourselves.
0. 6.
Yeah, you could choose those, yeah. But remember, if you plug in negative 6 here, you're going to get something huge out.
Oh, yeah.
Because it's going to be negative 6 times negative 3. That's going to give you, positive 18.
But
You're going to add 1. You're going to have to scale your graph, right? I know how much you guys love scaling graphs, so maybe you should try that out. Right? I'd be like, put it in 10 even squares. No, I wouldn't do that. So that's it. So are there questions about this brute force
Or
graphing?
are we just graphing it based off of that equation?
Yeah, you take a look at this equation, right?
Pick our numbers based off of that equation, create it, and then create the math to go with it.
There you go. Yeah. Yeah. Okay, so let's see now. Wonder if I have another one of these. Good. Wanted another one. Okay.
Can't wait to do another one.
I can't. And let's see now. I'm actually going to skip this one because I only have 11 minutes left. But we're going to do this one because this is a bit of a weird one.
Are we going to miss out on C applications?
Maybe. Oh.
Oh, it's still graphing. Never mind.
There's nothing that's going to save you in there.
Oh, no, we're just doing what we already
learn.
Okay, let's try another one of these brute force things, just so you guys have it kind of in your head for the homework. So for this next one, right? I have my equation here, right? I'm just going to solve for one of these. I'll solve for y. So y is equal to 2/3 x. Now with this one, it might help to choose some very specific numbers. And the reason why is because those specific numbers will give you answers that are not fractions. Yay. And when I say specific numbers, I mean numbers that when you plug them in for x are going to cancel with this denominator 3, right? So any multiple of 3 is what we want to put in here, right? Earlier we used -2. Here we're going to use -3. Okay, and let's see now. I'll put my scratch work down here maybe. So I have y equals 2/3 times -3. These cancel, and I get -2. So the first point is -3, -2. Okay, the second point, pretty much always going to be 0. If I plug in 0 for x, what am I going to get out for y?
Wait. Oh, never mind. Sorry.
0. Yeah. Yeah. So now I plug in my +3. Now I'll do that scratch work down below as well. So I have y equals 2/3 times +3. The 3's cancel, and I get y equals 2. Whoops, I just said y equals y. Y equals 2. All right. So those are my 3 points. I'm going to go ahead and plot them. I have -3, -2. That is right about here. I have 0, 0. That's just the origin. And then I have +3, +2. Right about there. Here we go. I've graphed 3 points. Now I draw a line through them to complete this. And I'd want to label those points, which I'm not doing because I'm running out a little bit of time here.
I'm not even drawing the graph.
Okay, that's fine. That's fine. So now I do want to get to this application because it's weird. You're going to run into a few applications like this where your scale is going to be strange, and the hardest part about these will be figuring out what scale to put on this. Okay, so for
Still don't know what scale.
Scale means like what's the difference between your tick marks on your graph.
Oh yeah.
And so if the difference between tick marks is 100, you have a scale of 100. Right? But this one's got a lot of decimals in it, so we're not exactly sure what our scale should be at the moment. So let's read this real quick. The average award A of student financial assistance per student is approximated by this formula, where A is in thousands of dollars and T is the number of years after 1994. Okay. Graph the equation and use the graph to estimate the average amount of federal student aid per student in 2018. Okay, we could do that. So first things first, we'll do the x-axis, right? And the x-axis, when we have a time problem, the x-axis is almost always t, right? So I'm just going to erase this x and rename it t.
Wait.
I know, that's strange.
Okay, I get it.
Yeah.
Wait, are you replacing the y with... Wait, are you replacing the...
Oh, yeah, and I will be replacing the y with a.
One.
Yeah.
Okay, I
Yeah.
can't remember what came first in the alphabet, and I really didn't want to.
Right?
I'm trying to look at, like, we already did this.
Yeah, and so you'll see here, this axis I've specifically labeled the opposite of alphabetical, right? Because t, I almost always do time on the horizontal axis, right? Now my vertical is a, so it's different than what the standard is. All right, so they've said that t on the horizontal axis is the number of years after 1994. So the 0 line could be 1994, right? And we'll say 1, 2, 3, 4, 5. Okay. All right, and maybe I'll label these 95, 96, 97, 98. $99, blah, blah, blah. Okay, so now I've figured out what my scale is on the t-axis, my horizontal axis. It's just a scale of 1, because they've asked us to count off by years. Now I need to figure out what the scale on my a-axis is going to be. So to do that, I mean, we can see that when t, let's just take a look here. What happens in the very first year? And I shouldn't say first. What happens when t equals 0? Yeah, a starts out at 2.5 when t equals 0, right? And so that's probably the first tick we're going to want to make on our axis. Right? 1994 is the 0 year. So I'm going to say, let's start out at 2.5 up here. And let's just calculate real quick. Let's say t was equal to 5, right? So if t is equal to 5, let's see how much a would be. And I'm just going to pull up my little calculator to do this. So just try and hold this equation in your memory. I'm going to go to my calculator and punch it in real quick. So I have 0.08 times the number of years, right? Remember, because it was t. And so let's see what happens after 5 years. Times 5 plus the 2.5.
Doesn't it look like this is in this chapter?
It's in the homework section. There's a different example of this in the actual chapter, because this is a weird example, so I wanted to give you guys 2 of these.
Hoping I can see the book read it out. And
No, the book's got a different example, and so that's going to be a good example to reference if you're not sure how to do this in your homework. Okay, so I got a 2.9 after 5 years, right? That's not a lot. We started at 2.5. After 5 years, we're only at 2.9. I don't know. I think a good tick mark for this might be by 0.5. What do you guys think? Right? And so the next tick mark would be up here at 3.0, then at 3.5, then at 4. So here's something important. I'm going to zoom in on this graph. Because we started at 2.5 and not 1, and our ticks are not in they're not a 2.5 scale, we put this little thing on the side. That means that the graph doesn't start there. There's something to the graph that we haven't really put on the page. Okay, so our first point, let's just do this with brute force, right? So I have my horizontal variable t, and then I have a, my vertical variable, right? We already know that when t equals 0, a equals 2.5. That's our first point on this graph. Then we also did, we just ran the numbers for year 5, right? So when t is equal to 5, I think we got 2.9. We're gonna have to actually stretch this out all the way to 2018. So we're gonna want to choose something maybe decent for our next one. Let's see what happens on year number 10. Okay, so I'm gonna go back to my calculator. I'm gonna plug this in for year number 10. Okay. So let me clear this stuff. Where's the clear button? There we go. So y equals 0.08 times t, which in this case is 10, plus 2.5. 3.3, okay? So let's go back. 3.3. All right, so now we have 3 points. Let's go ahead and plot some of these. So I have my 0th here is 2.5. Let's go ahead and plot that. And then let's see, now on my 5th year, 1, 2, 3, 4, 5, I have 2.9. So that is maybe right about here. Then I have on my 10th year, so that's 5, 6, 7, 8, 9, 10. I have 3.3, which is like right about here. Now I connect my points as best I can. All right, and so now here's the key of this problem, right? Does anybody mind if I erase my table that I drew over here?
Yeah, go ahead.
No? Okay, erasing the table. So the key to this problem is that they asked us to figure out what student aid was all the way out in 2018. So we want to take this graph and try to extend it out all the way into 2018. A little bit tedious. Maybe I should have done these years by twos, but we're gonna go for it. And this will be the last problem of the day, so don't worry, we'll get you out of here. Just a few minutes late. Okay, so we have 2000 here, 01, 02, 03, 4, 5, 6, 7, 8, 8. I'm gonna extend my graph a little more. Right, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, way out here. So I want to know, where will this graph land way over here on point 18? So what I do is I just try and extend this straight line out. Right? Let's see now. Whoa, what was that?
Form of an arrow.
Oops. Okay, so I want to take this straight line and extend it out a little more. Right? And then make an estimate of where this is. No, it's not that straight, and my tick marks are not that even, so this is going to be a terrible estimate. So I have 4, 4.5, 5, 5.5. What is that? Yeah, that's somewhere around there, so I'm going to draw.
That's like, yeah, 5.5.
Sure.
Exactly where you put the tip.
I don't know, this looks like about 5.4 maybe? It's an estimate, right? So I would say roughly 5.4.
Wait,
Where's the 3.3? Oh, right somewhere.
This one here, you mean?
Okay, so I have 2.5 down there. Got it. Where's the 2.9?
Oh, I'm sorry, this was the 2.9.
Yeah.
This one is the 3.3.
Okay, so.
And as you guys can see, like, you know, if you would have thought this out a little more than I did, like you would have said, well, maybe I should put these tick marks one every 5 years instead of every single year. You know, I didn't think this out first. I just started piling on.
Okay, so estimate. Okay.
Okay, so now just real quick before you guys take off, let's check to see how close our estimate was, to see how far off, how terrible my graph was really is what we're checking. So I have 0.08 times year, let's see now, 2018. What's the difference between 2018 and 1994? What is that? 94 is
18 plus 6
24?
Whew.
24 plus 2.5, 4.42. How close were we? Not very close. Would have I given you full credit though? Yeah, because obviously you know it's just an estimate. You extrapolate it out, and it's an estimate. I understand that. I can see that from your homework. So you would have gotten full points for that. The last little tiny bit that you won't be tested on, the difference between interpolation and extrapolation. What we just did was extrapolation, where we predict something in the future based on past. Interpolation would be if you plotted 2 points and you tried to estimate something in the middle of those 2 points. That's interpolation, but you won't be tested on that. That's just a little bit of extra info. All right, so thank you for your patience today. We didn't go over all the examples. If this homework is tough, it's okay. Don't feel bad about it. This is weird stuff, especially when they ask you to do all the scaling.
Yeah, don't feel bad about your mental breakdown.
No, you never should. All right. Thank you very much for you guys' patience.
Thank you.